tip number 3. This is mod 150. To see how it works, we're going to do a class on panel board, switch gears, and to see where we're at and breakers. We're going to describe switch gears, has some layout information on it about has some information on what and how far apart the bus bars should be, and it's going to be actually. We'll see how that works out. Switch gears, first method construction. This is really important. All this information here is about how far our bus bars are going to be apart from each other inside a switch gear. I remember in switch, we did a panel board like this, and it was only 4,000 amp rated. We had a technician in the union. He was working with the system. He actually used his wrenches and stuff in that system. He accidentally laid it on the bus bar. We went to go turn on power. Power turned on, and then he opened up the power panel to look at the switch gear. When he did that, he noticed, well, actually, he couldn't find his wrench. And then they turned on power because he figured he just lost it. But what he did was he left it on the bus bar. When he left it on the bus bar, they opened up the panel afterwards and they saw it there, and it was about inches from phase A to phase B. If that metal wrench would have touched A and phase B, it would have been like an explosion, and all kinds of problems would have been happening. This was on a government project, so be very careful, be mindful of the distances you have from each phases on your panel boards. Just, this is why it has regulations and distances. But be careful how it works. Like it's showing you here, they got phase A, B, and C. Your neutral ground gives you the distance over 1 inch, 2 inches, 1 inches. So when you start doing this, when you're working this stuff out, you got to make, when you don't know much about it, but when it's happening, and you just got to make sure that you're mindful of it. Doesn't when this power panel is on full blast, when you're looking at these distances, you're not thinking that it's a big distance in between each point, and it really isn't. So, like I said, the guy with the wrench almost caused a major problem, injury to humans or equipment. So be careful, mindful of what's going on. And this is a typical switch gear. You find a lot of these, your main pull sections, and gives you information what's going on. As soon as you set it all up, what happens is with this type of switch gear like this, all of it's connected, interlinked. It comes in and interlinked, all interlinked. You can't see. I wish they would show a picture on top how everything is interlinked from one to next to next to next. Because you have a main system coming in that connects them all to the same line, and each one has its own individual breaker. This breaker now takes care of another system, which is a panel board, and that's this happens on big businesses, big buildings, and stuff like that. It's really important to understand it and do a flow chart when you're there. There's a medium voltage switchgear view. This is just a typical, just trying to show you how they're constructed, and I never say anything like this, but I'm sure someday you might. Depends on what type of business you're in and what type of field of electrical. This is pretty important because when you're doing your testing, your phase to phase, phase of ground, and all these testing, if you're on the testing crew for the first time, you might go to a building for the first time and you might be doing some testing, but you don't have no reference. A lot of times there's zero reference, so you got to establish a reference, and you can establish a reference from this switchgear to the next switchgear, and you can if this switchgear over here is with so many ohms or voltage and or amps, and then this one's a little bit different, you got to see what's normal. So you got to establish a normal point. So this is what this is doing. It's telling you what the megohms. It's recommended installation of megohms. That's when it's brand new, when it's first installed. So you got to make sure that when you do this, you establish a point, the very first point in what you're working on, so that you can have a reference for future jobs. But you have to have a record. Always have a record. I have my red. I'll bring it in. This is pretty cool. It's not as fancy as this. This is probably high tech to what I have. The one I have is I just paid $600, and what it does is it actually identifies the hot points of each connector. If you have power coming in, it'll show at each lug, it'll show the heat around it, and it actually has a temperature around there too, so you kind of have an idea of what's going on. Also, this is really good for us for infrared, for heating that's in the ceiling. It's radiant heat. You put that thing up to the ceiling, you can actually see the lines where the radiant is coming from. You can't physically see it. You really can't really feel it because it's not that strong, but just a radiant, it pulls the heat down to you, and it's really comfortable heat, but you can't see what's wrong with it. But with this, you can actually see the heat lines, and I have some pictures of that. I'll show you guys. This is a very valuable piece of equipment to help you out in troubleshooting. Okay. DC testing. I'm not too familiar with DC testing, but if you work for MTS as an electrician, you guys can apply there. That all those motors are DC motors that pull the train, so they're very, very powerful motors, and it's a lot of information you'll get when you actually work on OJT, on-job training with them. So it's what you have in a book, read it, understand the best you can. But like a lot of companies who use DC motors are like the MTS systems with the trolley. Here's a switchgear problem. A rat got in, and the thing is, I think what's going here is that, you can't really see, but they want you to close up everything that's not being used. So if you're not using a breaker, a switch, a system of some sort, if you're not using it, you got to cover it properly, turn off the breaker, disconnect it somehow. In residential or small commercial, what we do is if the breaker's connected to the circuit that's not used anymore, we disconnect the wire from the breaker. We note what it's for, what it was for, and where it's going to. So you always leave the next electrician information so that we're all professionals. I've seen situations where handymen would just cut the wire, leave it there, then leave it for the electrician to find it, and have problems. Okay, here's ground fault systems. I just shown you how the ground fault assembly works, bonding jumpers and everything else. I never use a zero sequence method ground fault. This is just a typical or a type of way of troubleshooting and stuff like that. Something I haven't done. All right. Single throw, high level switches, high voltage limited switches. A lot of times when you have high voltage, you have these arc chutes. These are called arc chutes. And the thing is, what happens is those things, and these are like a plastic type of non-conductive type material. What it is, the arc chutes, when you throw that freaking lever, it's gonna go bam, because they're so high voltage. And when it does, it'll throw an arc in here in this area. You can't really tell, but that's why we have the high voltage limiting switches. And the single throw means you push it up and it just slams in, and they slam hard because it's activated with a spring. So as soon as you push it up, the spring pulls it in, slams it in real hard. But these are just different types of switches they want you to know. The bolt pressure switch, same thing. There's so many different designs, and they have rack out type switches. These are similar to what we used to have in the military. These are special type switch. So when you work on this type of system, it's just be mindful. They want you to be mindful of what's out there, and always ask your journeyman when you're working with somebody, what is out there, what is this for, how does it work? And if they don't know, you got to get that information from somebody who does know. If they're just installing it without understanding how to install or what the information is on it, get that from the superiors, because it's good to know what you're working on and how it works. Not everybody knows what they're working on, but you gotta really understand what you're working on. And if your journeyman doesn't know the answer, get it. There's a lot of bolt pressure switches. There's air switches. There's things like that we use. This looks like all automated, if you ask me. But anyway, there's this type of switches where you have to pump them. The actually switches, you pump them up, pump down like 3 or 4 times, then you slam them in there, and they actually activate. So there's many different types of switches. And this in particular one, it says it's a high failure rate due to lack of maintenance. So maintenance is key. It's a job in itself. Okay, instrument transformers. You have CTs, current transformers. You have regular potential transformers. These will basically give you your voltage. And current transformers, when you see current transformers, a lot of times you see those when you're reading voltages or reading amps. You read amps in a system. So what you do is you do CTs. You put a CT over each source, from line, and it will create the load. But when you clamp here, here, and here, what happens is this current transformer will read how much current is going through that system, and you cannot disconnect it. The primary. Here's a regular transformer, step up, step down. Just giving you basic. We're going to go through transformers, but you got your primaries are H's, your secondaries are X's. It's always that way, showing the lines of flux, the current path, or the current would be going through here, or your voltage. So this is the basic transformer setup, and this is how they all work. You can have air transformers, core transformers, so many different styles of transformers. Liquid field transformers. Type of current transformers. I usually, We usually use these ones. I haven't seen the other styles. Oh, there it goes. It never fuses. Current transfer in the secondary circuit is open. The primary current will produce a dangerous high voltage across both windings. So be careful when you work with these. Get some experience. It's the best thing. There's some abbreviations. You know, this is closed. This will be open. Show what it is. Same thing here. Working with motor controllers, this is how you usually work with your motor controls. Go start, stop, run. It's telling you information here, what's going on. It's spring return, just giving you information. Stop means everything's off. That's off. The red should be on when it's out. Run, put this to the run position. Number 1's gonna be on. Number 3 is gonna be on. 1 and 3. It's a maintaining contact for a motor, right? If you hit start, then this is going to be started up. So now 3 and 4 will be started. You put this to start. 3 and 4, the light will turn on. The maintaining contact will turn on, which allows current to go through the maintaining contact to start the motor, to run the motor, and it'll always be that way. Every motor will have, well, I shouldn't say every motor, but most motors of high capacity will be on this type of a system. This is typical of a blueprint. This is what you always see on your blueprints. I have some blueprints to show you guys when you come in, but your typical, your E-drawings will have this. And they're just showing you your main line coming in, your transformer, how it gets from the city to you, from you, goes to your main switchgear that we looked at, that big switchgear system, how that's connected to each other. Each breaker comes off, feeds another sub-panel, or I don't know, something else what this is. Could be a transfer bus or something like that. And same thing here. You have it says 3C 250 kc mills. So direct burial. Wow. So anyway, this is going to be a direct burial cable. I don't know how that's possible, but that runs a 3-inch conduit. That's what it's for, or it should be 3-inch conduit. And then it comes through here, it comes through the system. MCC, it's a motor control cabinet. This is all motor controls. So this is all this is a switch gear. So this is all your motor control. And then these all, motors, different types. Chiller, dryer, slurry pump. I don't know what that stuff is. But anyway, this is just a typical layout, a flow chart of what you're going to be looking at on the main switchgear. Then you get into details when you look through your blueprints and start looking to see how it's connected. Elementary schematic diagram. I believe we're going to be doing more motor control systems. This just shows you the basic of how it works. If this was cut, this would not run because you need 3-phase to run this motor. Because you can have your motor has to run in a sequence from A, B, and C. If it's out of sequence, it's going to run backwards. This is, if you see, it's all in line. The stop is always in line. You push that, it disconnects the system. The motor contacts come out of contact, and this will open up. When it opens up, the motor dies. Now, this is actually up higher, so it's not touching it. As soon as you touch it down, you connect the switch, then the motor gets energized, turns on the motor contacts. It's right here, 1, 2, and 3. It slams in. You have your overloads, and then your motor starts to spin. This is typical how every motor control works, and this is just a basic diagram that that's very fundamental, because this is how everything works. You might have other wires doing other things, but this is the basic model what you will have to be learning. It's something, if you work with any kind of motor controls, this is something you will need to know. Point-to-point contact. I like having this because it's easier for us to troubleshoot. Let's say you go number 6, boom, you read it, D, it reads 5, you go to 5D, it's telling you when you do your ohmic value, you see the ohms, you can see the value. You might not, all these wires will be in a harness. You can't see those wires. But if you look at 6 and go to 6, and if it rings, you good contacts. Even when you have voltages, you can start testing out your voltage. You'll have another schematic that will show you the voltages of what you need, or you can assume because you see the whole flow chart, the whole diagram. Cable connect diagrams. It's very similar to what you're seeing. It's very similar in how it works. You also DC in, check your voltage. Always check your voltage first. Make sure you have proper voltage coming in. Each one of these represent a point over here, and you should. I never really dealt with something like this, but I've seen some that I've worked on, but not a whole lot. And at first it's kind of mind-boggling. Then after you understand it, you just figure it out real quick. That's the difference between a journeyman and apprentice. A journeyman will sit on something a bit longer to comprehend what they're looking at, and as long as you have the basis of understanding, it won't be as hard for you to grasp the information. Manufacturer drawings, not too sure. I'm familiar with this type of information. So a lot of times when you have something like this, a lot of times when you have manufacturer information drawings, they're going to have it's MCMC front view. So this is a whole motor control system. This is 1, 2, 3, 4. Okay, I understand this now. Because this is the motor control system. So each one of these is a motor controller, and they go to a different location in the building, the MCC center, and that's just showing you how it looks, in general. Okay, here's your motor control center stand units diagram. This shows you how it works. Look at, here's your vertical bus. This is power coming in, circuit breaker or switch a few, same thing here. But you got your L1s, L2s, L3s. Actually, this is your lines. That would be your loads, but I don't know why it's coming like that. But your line is always coming from the top. So let's see what it says here. It just says it's a motor control center standard unit wiring diagram. But this is just a basic drawing of what you'd be looking at. That's about it. And another thing is, a lot of times when you have a problem or complication with the unit, there's something, every motor, every item you ever work with will have a manufacturer number, manufacturer email, or location, anything here. It'll be something about that motor. So it's best that you, if you don't understand it fully, you give them a call, because their equipment, they know their equipment. You could tell them, okay, this is the drawing number, this is a spec of this unit. They'll pull that up on their side and they'll guide you on what's going on. But you have to understand how it works so that they can tell you what to do, and you guys can troubleshoot it together. I've done that many times. I've learned a lot. Okay, here's a more complex motor control system. Like I was telling you guys, remember that diagram up there for motor control? It's pretty much the same. Power in, you have you maintain contacts, overloads, motor, and that just runs that. It is what it is. And here's another one, another system. Have some overloads here, T1, T2, T3. This is when it's a T side, means it's going to the motor. Here you go, your line 1, 2, and 3, power coming into it. You maintain contacts, your overload system. So the same thing is that up there. You're just breaking all this stuff in between are switches, levers, auxiliary units, and stuff like that. And then this gives you information. This right here is your obviously your fuses. This could be the incoming power that comes in, takes care of everything. Or actually, this is L1, L2. This is showing me that power in, X means power out, is coming to a low voltage transformer. It could be transferring it down to from 480 to 120 or 250 or 277, whatever. It's going to be lower voltage for controlling voltages. Okay. Here's some panel boards. What this diagram is so awesome. I wish every building had it. I think they do, but the older ones absolutely don't. You go P1 to P15, tells you the location, the amperage of that system, tells you number of circuits in that panel board. Man, this is like awesome. This is like, when you find something like this, it makes troubleshooting, finding problems a lot easier and to identify. And then if you need to add more power, so if you're in a boiler room, you need to run power and you don't know where to look, well, you have this information. It's in the boiler room somewhere. Something that would be even better would be a location, the actual location of where it's located, but that's not likely. Okay, you have here's your main feed, bus bars, runs, heights, and stuff, which is pretty cool. This is just typical panel board. See that little red light there? Looks like that one's in fault. It's cleared, so I'm not too sure what's happened there, but it looks red up there. So this is probably a square D unit. It's just a typical panel board you'll be finding in any particular project or job. But not necessarily all of them look like this. This is what it looks like internally. This is your buses, ABC, or it's a single phase, so it's AB, 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 or AB, 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 AB. Oh, here it is. Yeah, AB, so you can see how it's connected. The A's and the B's are connected. So it's a single phase 3-wire system. And these represent breakers. And you always count 1, 2, 3, 4, 1, 3, 5, 7, 9, 11, 13, 15. Every third one will be blue. When you go to high voltage, every third one will be yellow. There's a lighting and appliance branch circuits. I'm not too familiar with, I'm familiar with lighting panels. This is a 3-phase, shows it's a 3-phase unit. It can be controlling, when you use 3-phase units, you usually control a lighting disconnect. A lighting disconnect is very much like a motor disconnect. They look very similar in style and function. Like I said, typical ABC, so it's ABC, 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 brown, orange, yellow for high voltage, black, red, blue for low voltage. Like I said, always the third leg is going to be blue or yellow, so you know what phases that you're on and how it's working. Here's another one. Here's another phase system that we're working on. That it's a typical 3-phase. If you use 3 phases, these 3 phases, they can be used for the bakery equipment that's big and useful. But the thing is, you have a B phase that's going to be a high leg. The high leg, it can be dangerous if you don't know that it exists. A lot of times you find high legs in panels that are older, or locations that are older, or specified panels for certain buildings and businesses. Okay, here's a system where it's showing you it's a high leg, delta high leg. Here you go. So here's your high leg. You're looking at it's about 208 volts. So it's about approximately 209 volts. I sent you guys a video when I worked at Chipotle, and this is what they had. They had the high leg in there, and it was marked. It was tagged. And this says it should be tagged orange. The one I had was tagged yellow because they had it on the C phase. But normally your high leg is on the B phase. So I'm not too sure why that is different from what I saw and what this is. Okay, this breaker right here, push the trip on off, test jack. Sometimes these breakers have has functions at the bottom where you can actually dial into how many amps you can raise it, lower it, the voltage, the amps of how this breaker is going to trip. I've seen them where when they sent them out, they have the dials all the way to left down to like 0 or 1, and every time you put a load on it, it would trip this breaker constantly, and everything was fine. So a lot of times, a lot of journeymen don't realize that this breaker has a function, and they rack their brains because every time they turn on the breaker, it stays on for 10 minutes and it trips at a lower amperage. So that's why you need a clamp on amp meter. You clamp onto it, test it out, see where you're at. If it's tripping at lower amps, then most likely it's your adjustable breaker is not adjusted properly. Branch circuits, same thing. The branch circuits, breakers. Looks like this is some Murray. Anyway, they're two different styles actually. But anyway, this is just a typical breaker. Power comes in. Always, when you look at these breakers, you gotta look at the footprint. Flip it over, look at the footprint, see how it's connected. Look at your power panel, see how it's landed in there. Always identify your panel. It's very important to identify your panel to the breakers because there could be two different items and it's not good. All right, this is Mod 153-3, and this is just a quick review of what's going on for this module. We'll be coming to class soon, so hopefully we can get our hands-on training. I can get you guys up to par quickly of what the standards are in electrical, how you install items, and how you install breakers, panels, switches. I'm always constantly thinking of how to do things for you guys, to show you guys, let you guys touch things, and so you guys get that tactical feeling of being an electrician. Because when you guys go out in the field, it's gonna be, pretty much, if you say you're green, if you're first of the first, they're gonna look at you and say, you know nothing. But when you leave this class, I want them to say you're first, you know nothing, but then you say, well, I could do this, I could do that, I could do this. But the thing is to have confidence in doing it. That's number one, having confidence in what you do. So I'm trying to come up with a plan to give you guys confidence to do things on your own. If I ask you to do something in our labs, I just want you to know how to do it. Just get up, get your tools on, get working on it without even thinking twice. That's kind of confidence you guys need to have on the field, and not so much, be timid of what you're doing, because this is what this class is about, is being confident in what you're doing, and that's going to move you forward quickly. All right, if you have any questions, please email me, text me. Thank you.